So I'm going to try to create a proof for you that no matter how you draw one quadrilateral, if you connect the midpoints of such quadrilateral, you will always result in a parallelogram. So no matter how wacky the quadrilateral you draw is, and let's start with a wacky quadrilateral. We've got a point here at 0, 0. We've got a point some distance away from the origin. I'm just going to make an arbitrary distance, 2b. Do you agree that the y-axis is still at 0? The y-coordinate of this point is still at 0? Oh, this guy, I have no idea how far this is in the x distance or in the y distance. So I'm going to call those distances 2c and 2d. I'd like that d to be neater. And again, I have no idea over here for this fourth coordinate, so I'm just going to call those 2e and 2f. And the story goes that if we connect the midpoints of these four sides, no matter how randomly we drew the original quadrilateral, the result will be a parallelogram. And the author, Paul Lockhart, the author of the article we read today, Reality and Imagination, states pretty boldly that this is a parallelogram no matter what. So I'm going to flag the sides. Sides with matching flags are parallel to each other. And I'm going to try to prove it. If I can prove that these two sides are parallel, no matter how I draw the initial quadrilateral, and that these two sides are parallel no matter how I draw the original quadrilateral, then I will have done what Paul Lockhart asked, which is to prove that no matter what quadrilateral you start with, if you connect the midpoints consecutively, the result will be a parallelogram. So I want you to remember something from your algebra study, and that is that two lines are parallel if their slopes are the same. And we're going to try to prove that the slopes of the quadrilateral, the sides of the quadrilateral A, B, C, D for opposite sides are in fact the same. In order to do that, I need some coordinates, right? Because the slope formula is y2 minus y1, that's the difference in the y coordinates, over x2 minus x1, that's the difference in the x coordinates. So I need values for these coordinates. So take a look at A here. We know it's on the x-axis, so therefore its y-coordinate's going to be 0. And we know that it's halfway between this first point and this second point. We called that distance 2b. Halfway from nothing to 2b is a distance of b. So there's our first coordinate. And we got that coordinate simply by averaging the x's and the y's. So you may not have realized right away that we were averaging the x's and y's, but that is in fact what we did. So if we average the x and y coordinates for any of these points, we will have coordinates for A, B, C, and D. So let's start with B here. The average of 2C and 2B, and the average of the y-coordinates 2d plus 0. That's a 0. There we go. So let's simplify that. 2c over 2 plus 2b over 2. These values are the same. And 2d plus 0, well that's just 2d over 2. And that allows us to do some canceling. So the 2's cancel in each of these fractions, and keep track of where we are. We have, in the most simplified version, we have C plus B for the x-coordinate, and D for the y-coordinate. So let's go ahead and bring that all up here. You can rewind the video if you want to see that the average of the x's and y's done again. But the midpoint, or the distance halfway between this point and this point, has a value of C plus B, comma D. And we can do that all the way around the quadrilateral. Let's average to E and to C. And let's average to F and to D. When we simplify that, we have 2E over 2, 2C over 2, and 2F over 2, plus 2D over 2. That allows us to do some canceling. So the 2's cancel in each place. And when we simplify, the result is E plus C, comma F plus D. So we're really just using the algebra that you got good at last year, or that you'll practice to get good at this year. And we have a general point of some distance that is E added to C in the x direction, and some distance that is F added to D in the y direction. So that's our coordinate for C, the third point on the quadrilateral created by connecting the midpoints of the four sides of any random quadrilateral. And let's get the coordinate for point D by averaging 2E plus 0. Oh, this is another nice one. Easy, because we don't add anything to it. And 2F plus 0 in the y direction. So we need to find that average for D. And when we simplify that, we have 2E over 2, comma 2F over 2. And we simplify that one more time because we can cancel the 2's, and we have the coordinate EF here at D. Okay, so now that we have coordinates, we can find slopes. If slopes are the same for opposite sides, then we have a proof that no matter how you create an initial quadrilateral, by connecting the midpoints of the sides, you'll always have the same, you'll always have a parallelogram. So at this point, we can get rid of the first quadrilateral, because now we're just dealing with the one created by the midpoints. So let's take a look at these opposite sides. Let's take a look at DC and AB. If we can prove that their slopes are the same, then we can prove that those two lines are parallel. So remember the slope formula. Add the y's, or sorry, subtract the y's, f minus 0, f and 0, divided by e minus b. And then simplify. M is f over e minus b. Okay, so we have a slope for this guy, f over e minus b. That's good news. If we can prove that the slope for AB is the same, this was the slope for segment DC. So let's look at the slope for AB. We're going to compare the y's and the x's. So D minus 0. Wait a minute, I got to make sure I did this right. F minus 0, that's F minus 0. That's this guy to this guy, and E minus B. Sorry, I put the slope in the wrong place. The slope here is M equals F over E minus B. So we found the slope first for AD. So this is AD. So in that case, I want to find the slope not for AB. I want to find the slope opposite AD, and that's line BC. So we're going to deal with this guy right now and see if the slope is the same as the one we just found for the side opposite. So compare by subtraction. We're going to subtract the y values. So f plus d minus d. That's f plus d minus d divided by e plus c minus this value, e plus c minus the quantity c plus b. I put parentheses around it because it's a binomial and we're going to need to distribute the subtraction. So when we simplify this slope for segment BC, we have f plus d minus c. Well, that's just f. And e plus c minus b. C minus c is nothing. So that's f over e minus b. Is the slope the same? That's really good news. These two sides have been determined parallel. If we can do the same thing for these other two sides, that's this guy here and this guy here on this generalized triangle, quadrilateral, then we will have our proof. So let's work on those two additional slopes. Let's find the slope for DC. We need the y value, f plus d, this guy here, minus f over e plus c, this guy here, minus e. The slope for line segment DC is f plus d minus f, well that's d, over e plus c minus e, that's c. So d over c is the slope. If we find that the slope for line AB is the same, then we will have a proof for this very bold statement that no matter how you connect the midpoints of any quadrilateral, you will always get a parallelogram. So slope for AB is d minus 0. Well, that's a nice one. C plus b minus b, that's d over c. Slope is d over c. Thus, it is proven. If opposite sides have the same slope, the quadrilateral is a parallelogram. That is an example of the kind of proof you will be writing this year. You will write proofs like this. Now, today's lesson is not the kind of thing where you have to memorize this. It is simply for you to take a look at and process to the extent that you can. Do not study this proof further. Simply pay attention for this 15 minutes, and your brain will grow.